Task 4, Tia is contracted to expand a rectangular deck that currently measures 10 feet by 6 feet. So you see here it's 10 feet by 6 feet. Tia plans to increase the length and the width of the deck by the same amount. So that's showing this image down here. Here's the original deck. We're going to increase this length by X, and we're going to increase the width by X. By how much does she need to increase the length and the width? Oh, she wants the new area. So I want the new area. So basically the area of this whole, I can't really see that good. Let me pick a different. We want the area of this whole new shape, that area, to be 165 square feet. Okay. So first, let's kind of merge these two pictures. We know the length from here to here is 10. So then the length of the new deck is 10 plus X. Okay. I know the length from here to here is 6. So, sorry, the width. So the width of the new deck is 6 plus X. So the area of the new deck is that 10 plus X length times width, 6 plus X, again in parentheses, we're multiplying by the whole thing. And I want that area to be 165. Okay. Now, you might be like, hey, this is already factored. It kind of is, but does it equal 0? Yeah, no. So I'm going to have to unfactor it and set it equal to 0. So we're going to have to do some distributing. So 10 times 6, we got 60, plus 10 times x, 10x, 6 times x, 6x, times x is x squared, equals 165. Okay, so now we do standard form, x squared first. Now 10x, 6x, 16x, plus 60 equals 165. Now, to solve, step 1, set equal to 0. So I'm going to have to subtract the 165 from both sides. So x squared plus 16x plus, minus, because that'd be a negative. 165 minus 160, 105 equals 0. So now we're set equal to 0. So step 1, set equal to 0. Check. Step 2, factor. So now we need to factor. So what are the factors of? And if you don't want to cloud up your problem, a lot of times people will do it off to the side. The factors of 105, which I don't know off the top of my head. Well, I know 1 and 1, negative 1 and 105. Again, always keeping in mind when I add them, I want to get that 16. So let's go ahead and let's try some other ones. So 105 divided by, what about 2? No, it doesn't go in evenly. We kind of want even numbers right now. 3 and 35. Okay, but those add to either 30. Well, I need negative, so one of them's going to have to be negative. Those add to 32, not 16. Okay, 105, 5 and 21. What if the 5 is negative? Because we need to get negative 105. Negative 5 and 21, that is 16. Hey, we found it. Once you find it, you don't have to keep going. Okay, so negative 5 and 21. Right? Negative 5 and 21. Again, you can always, negative 5 and 21 is 16. Yep, it works. Okay, so we have our factors. Negative 5. So x minus 5 and x plus 21 equals 0. So now I'm going to distribute that off to the side here. X times x is x to the second. X times 21 is 21x. Negative 5 times x, negative 5x. Negative 5 times 21, negative 105. Put together my middle terms. Okay. There are so many checks along the way to make sure that you did it right. I really love factoring quadratics because you can check it. Like, does it really multiply to give me what I hope it does? Which it does. So now that we have it factored, set each factor equal to 0. X minus 5 equals 0, or x plus 21 equals 0. I expect to see all of this work when you're working these problems, so be prepared to show that to me. So now we're going to add 5 to both sides here. X equals 5, or subtract 21 from both sides. X equals negative 21. So we technically have two different options. We can either actually increase this space by 5 or by negative 21. I ask myself, do any of these not make sense? It doesn't make sense to do negative 21. Negative 21 makes no sense, but we can increase it by 5. And it does make sense in terms of this problem. Like the deck was originally 10 by 6. Could it now be 15 by 11? Sure, it can. And 15 times 11 is actually 165. So by how much does she need to increase the length and width? She needs to increase by 5 feet.